Can see? Okay. Basically, this one summarized for you. What are the things that you need to
New
know?
chapter, Chair.
Chapter 22, focus 22.
Oh.
Okay now.
Hmm.
Okay. What is the answer for this one? What is your answer?
This one, boy teacher.
Boy. Okay, okay that lor. No. Apple. Where did you go wrong again? Make sure you write down. That's part of your learning. Where did you go wrong?
Careless mistake, Chair.
Careless, cannot afford that. Number 2. Which of the following graph shows a variation of U or V with U, where U is the object distance and V is the image distance for the convex lens? What's the answer?
Donkey.
Let's see, go to the lens formula. That's the first thing. That's the lens formula. You want U and then 1 over UV. So you want V. Sorry, have I done something wrong here? Okay, I subject 1 over V. Okay, so I take this one across. Then I common factor UV. So U minus F. I think I've done something wrong already. Sorry. I just discovered I've done something wrong already. It should be V here. Should be U here, not V. Because you want U. Right? You want U. So we subject U first. But doesn't change much. It just changes to V, that's all. Set changes to V, that's all. So then you invert it. Sorry. What am I doing? It's completely. Yeah, what am I doing? 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 Never mind. I leave this one out first. I will solve it and then go over with you. Okay, leave this one out first rather than spend too much time on solving this problem. I don't know why I'm so careless. Okay, let's go to number 3. When an object is placed in front of a concave mirror with radius of curvature R at a certain distance, an upright image, which is 3 times the size of the object, is seen. What is the distance between the object and the mirror?
C, teacher.
C. Let us see. Upright means the object is less than the focal length. That's the most important thing that you should be able to deduce. Right? It's a virtual image. Okay. Your focal length is half of R. And then for magnification, okay, magnification is V over U. And then since it's image is on the same side as the object, it's virtual, so you put a negative sign there, minus 3U, and use the formula, the lens formula, put in your value, right? R over 2, this one is U, 3U, so common factor is 3U, so that will be 3 minus 1 is 2. Then invert it. I take the U across there, take the R across there, put 2 and 2 will cancel off. No, answer is B. Ken, anything not clear?
Okay, so far.
A picture or draw a diagram, then you can see what is happening. Okay, you should be able to guess roughly the answer is either these two only. Right? Because you are 3 times bigger, 3 times bigger than your V is 3 times larger than U. Okay, let's go to number 4. An object is 20 cm in front of a convex mirror. I have a picture. What is a convex mirror? And the image is located 15 cm behind the mirror. Find the focal length of the and radius of curvature of the mirror. Okay, what's the answer?
C, teacher.
Right, let's see. Right, use the lens formula. Write down what is given. 20 cm in front of the convex mirror, 20 cm. And then V is 15 cm on this side. So it's going to be virtual. That's why I put a negative sign there. Go to the formula to find your focal length. 1 over F is 1 over 20. Is minus 15. Okay, so use your calculator. You should be able to get 60 cm. And radius of curvature is double, 2F, it's 120. Answer is donkey. Okay. Any comment? Anything not clear? Can anything not clear?
No, okay.
Let me just make a note first so that I can remember to try this one out. Okay, let's go for the okay. What's the answer for this one? The arrangement of a diverging lens and a converging lens with focal length 15 cm each of them 15 cm focal length, shown diagram below. The lens arrangement is focused to a far object with the diverging lens in the front. Right? Far object is here. If the separation of the lens is 15 cm, the image from the arrangement of the lenses is, what's the answer? Yep. Why so long? Should I done it at home? Okay. The first thing, image of the diverging lens is at the focus on the left-hand side. Right? Image, because you are viewing the object from here. Right? Infinity on the left-hand side there. So you draw a diagram, the focus, the ray should focus to the object at the focal point there. Right? Focal length number here. So it's 15 cm. 15 cm. So now this one becomes the object of this converging lens. So it means that the distance is 30 cm. 30 cm is double the focal length. So the answer is donkey. If not calculate out, put in the formula. Right? Focal length 15. We are now looking at converging lens. Object distance 30 cm. Put in the formula and calculate out. Can?
Can.
Okay. If okay, then we carry on. Have you copied what you want to copy?
Well, I mean, teacher is recording, so yeah.
No, you still have to copy. That's part of your learning. Not everything you
Yes,
will
sir, yes, sir.
you go to recording. I think I
Hmm.
shouldn't recording for you already. You are getting too lazy already. Part of your learning, you must write in your book the answer.
Okay, sir. Okay.
Basically, you don't need to calculate. It's 2f. The object distance is 2f. The image distance is also 2f, so it'll be real.
Hmm.
You need to put in the effort. If not, your grade will not improve. Cannot learn from you for you. You have to learn yourself. This is part of your learning process. After teaching you, you have to do your homework. Anyway, I'll send you the worksheet for tomorrow. You can download it.
Hmm.
Okay, have you got all?
Yeah.
Okay, let's try number 7. We leave number 6 for you to try out yourself. We try more of the STPM question. The convex lens with focal length f form an image of the object as shown in the diagram below. Right? That's the image. F1 and F2 are the focal point of the lenses. Focal point of the lens. What is the focal length of the lens? Okay, this one trying to be funny, that's all. Trying to make a lot of maths involved, that's all. What's the answer? Yep. Okay, write down what is given. Object distance, let the focal length be f, 10 plus f. Image distance, f plus your 15, right? It's a real image. And put into the formula. Let that formula. Okay. Right? Denominator is that. So this becomes f plus 10, f plus 15. So there's 2f. 10 plus 15 is 25. Okay, a lot of maths, that's all. Cross multiply. Cross multiply. And then expand that. F squared, 15f. 10f is 25f. 15 times 10 is 150. F times 2f, 2f squared. F times 25. Then simplify that. Right? That one go off. One go off. Take this across there. F squared is 150. So F is 12.2 cm. Can didn't do your
Can.
homework.
I did a bit.
No excuse. Not big one. You have to learn yourself. I cannot learn for you. At the
Yes,
moment, I'm the one learning. You are not the one learning. That's a weakness. The more you do, the better you'll be. The better grade you will get also. Physics and maths like that. We teach you the basic, then you up to you to apply the formula, learn to apply the formula. That's the hardest part. But that's how you learn your physics and maths. If you have to do well, you have to do continuously every day. As a teacher, teach, you have to do your homework. Anything not clear?
No, all okay.
Okay, let's go further then. Okay. How about this one? An object is placed 6 cm. I think we won't bother about. Okay, we'll try this one. Since it's a clone STPM question. Object is placed 6 cm in front of a concave mirror with radial curvature 24 cm. Let's have a picture. That's a concave mirror. That's how it looks like. Which statement is true about the image formed by the mirror? Yep. What's the answer?
The answer, B.
Sorry, what is the answer?
Boy.
You're not putting your thinking cap. Right? What is the focal length? What's the focal length?
Focal length.
1/24. Huh? What's the focal length? You should be able to tell me from the question what is the focal length?
6 cm.
No. 6 cm is the object distance. Focal length is the radial curvature divided by 2. It's 12. So straight away, I know your answer is wrong because it's supposed to be virtual image. Right? That is your radial curvature. The focal length is halfway. Halfway is 12. 6 cm is halfway. Right? So it's virtual. It's going to be enlarged upright. So you can roughly guess the answer is this one. Right? 6 cm object distance. 24 divided by 2 is 12. Focal length. Right? I use the formula. You want object distance. Take this one across there, you get 1/12 minus 1/6. Okay, so you get minus 1/12. So it means it's on this side. 12 cm behind the mirror. Okay. Okay, copy whatever you want to copy.
Copy ready, teacher.
Okay, how about this one? An object is placed at a distance y. There's a distance y in front of a panel convex lens so that the image is formed at an equal distance y behind the lens as shown in the diagram below. If the reflective index of the lens is 1.4 and the radius of curvature of the curved surface is 25 cm, what is the value of y? Okay, what's your answer? You need to calculate the focal length first using the lens formula. Can work it out yourself and then give me the answer. Right now, object distance is u. Image distance is O. Object distance u is y. Image distance is 2y. Your R1, right? R1 is for this part there, 25 cm. This is flat. Flat means infinity. The curvature is infinity. N1 air. Outside air is 1. N2 is for the glass. Use the lens formula. Put your value inside. 1/f. 1.4 divided by 1. 1.4 minus 1. 1/infinity. 1/25. So you get 62.5. Yeah, use the lens formula now. I got the focal length of this Pinot convex. Okay, put in your equation there. The focal length is 62.5. Your u and v is y. Right, remember this is thin, so we are not worried about the thickness. Okay, can or not? Anything not clear?
Okay.
Okay, then copy whatever you want to copy. Okay, have you copied what you want to copy? Or need more time?
No.
Okay, I think I will leave this one for you to do. Let's try this one. A beam of ray incident normally on a converging lens of focal length f1 placed in contact with a diverging lens of focal length f2 is shown in the diagram. Given the diagram, the focal length of the lenses combined is f, but which of the following is the correct expression for F in terms of F1 and F2. Okay, what's your answer? Yep. Yep. What's the answer?
Boy chưa?
Right? Combination of lengths. Refer to your textbook or to my lesson. I've derived for you this formula. Okay. And then you just work it out. Common denominator, F1, F2. Just F2 here, F1 here, add them up. Then you want F, invert it. This one go on top, this term bottom there. Then see where is the answer. Boy. Okay. Okay, let's do one more. Then let's take a break. After that, we do a structure question. If you haven't done, you better do it. Okay. An object is placed 4 cm in front of a convex mirror with radius of curvature 40 cm. Which of the following statement is true for the situation? Yep, what's the answer? Yep. What's the answer?
C teacher.
Cannot be C, cannot be real. When it's a convex mirror, your answer must be virtual. Right? Virtual, but always smaller. You are not studying. Just your convex mirror. Right? Image is always smaller, no matter where it is, always smaller. So you can work it out. If you don't know the facts, right? 4 cm of the object. That one is 40. So you divide by 2 to get the focal length. Right? It must be a negative line because there's a sign convention for convex mirror. The focal length is negative. So image is virtual, upright, diminish, and form behind the mirror here. Right? I've shown you roughly the sketches, regardless of the position. So you don't know, you can calculate out. Right? That's the answer. The answer is A. Okay, we will remember that, right? No matter what it is, it's always here, the image. And if it's always here, it's always diminished. And it's always upright. And it's always smaller also than this one. You don't know, then calculate out. That's how you calculate. Anything to ask?
No chưa?
Okay, I think we will take 5 minutes break. If you haven't done the structure one, can do the structure one. Anything else you want to talk? After that, we go to B, section B and section C. Anything else you want to ask? Yep. If not, we take 5 minutes break.
Yeah, 5 minutes break chưa?
Okay.